Betelgeuse, a red supergiant. Betelgeuse, a red supergiant star situated in the constellation Orion, is a grandiose wonder that has enamored researchers and cosmologists for a long time. If placed at the center of our solar system, it would extend beyond the orbit of Jupiter, dwarfing even our Sun. This gigantic star is not only massive but also undergoing significant changes that could lead to a catastrophic event of rare magnitude. Astronomers, including the renowned scientist Brian Cox, have expressed concern as Betelgeuse has been sending unsettling signals through space. These changes have raised one pressing question: will we witness a massive explosion that could forever alter the night sky? The enigma of Betelgeuse. Stars are born, live, and die in ways that often defy our understanding, and Betelgeuse has become a subject of both awe and concern. As a red supergiant star, Betelgeuse is located near the edge of our galaxy and has been a point of interest for astronomers. It is colossal and ancient, its reddish tint and fluctuating brightness attracting the attention of scientists and casual stargazers alike. For many years, its variations in color and intensity have intrigued experts, but recent developments have raised even more questions about its future. Betelgeuse is nearing the end of its life cycle, evident in its enormous size. This star is approximately 700 times larger than the Sun. To put it into perspective, if Betelgeuse were to replace the Sun, its outer surface would stretch beyond the orbit of Mars, engulfing Mercury, Venus, Earth, and Mars. Evolution and life cycle. At around 8 to 8.5 million years old, Betelgeuse is relatively young by human standards but ancient in terms of stellar lifespans. Over millions of years, it has undergone dramatic changes, evolving from a hot blue star to the red supergiant it is today. The evolution of stars like Betelgeuse results from the continuous interplay between nuclear fusion and gravitational forces, causing the star to expand and contract over time. The red hue of Betelgeuse indicates its cooler surface temperature compared to other stars like the Sun. While the Sun's surface temperature is approximately 5,500 Kelvin, Betelgeuse's is much cooler, around 3,500 Kelvin. This cooler temperature allows Betelgeuse to emit light at longer wavelengths, giving it its characteristic red color. However, this color shift is not merely aesthetic. It provides valuable insights into the star's internal processes and ongoing evolution. Changes in color and brightness. Betelgeuse's color has not remained constant throughout history. Historical records dating back to Roman and Chinese times describe the star as yellow. It was only in the 9th century that Arabic astronomers noted its shift to red. This change in hue reflects the star's evolution, marking its transition from a hotter, younger star to the cooler red giant we see today. Moreover, Betelgeuse is a variable star, meaning its brightness changes over time. These fluctuations, observed for centuries, include both short-term cycles lasting days and long-term cycles spanning years. Sir John Herschel, a prominent 19th-century astronomer, documented these cycles as early as 1836. However, Betelgeuse's brightness anomalies remain a mystery. Unlike many stars that follow predictable brightness patterns, Betelgeuse sometimes deviates from this norm, suggesting complex and poorly understood processes within the star. The mysterious dimming of Betelgeuse. In 2019, astronomers observed an unexpected and dramatic dimming of Betelgeuse. This event, known as the Great Dimming, sparked a flurry of theories and debates within the scientific community. The star's brightness began to fade rapidly, losing light at a rate of 0.01 magnitudes per day. By February 2020, Betelgeuse had reached its dimmest state in recent memory. This was particularly notable since Betelgeuse is usually one of the brightest stars visible to the naked eye, even in areas with significant light pollution. Its sudden dimming was noticeable to casual observers and raised questions about what might be happening to the star. The challenge of time and light. One of the challenges in studying Betelgeuse is the delay in observing its activities. Light takes a long time to travel across vast distances, so when we observe a star like Betelgeuse, we are actually seeing it as it was in the past, not as it is right now. For Betelgeuse, the light we observe today left the star about 650 years ago. This time delay complicates our ability to track rapid changes in the star's behavior, making it difficult to predict or understand the causes of these changes in real time. In 2019 and 2020, astronomers, including Andrea Dupree, the deputy head of the Center for Astrophysics at Harvard and the Smithsonian, closely monitored the star using the Hubble Space Telescope. These observations provided valuable insights into the workings of a variable star like Betelgeuse and revealed that the star was undergoing massive changes in its outer environment. Hubble Space Telescope's contributions. Hubble's ultraviolet observations provided crucial data on the star's atmosphere and internal processes. Spectroscopic analysis of Betelgeuse's light revealed that material was being ejected from the star's surface at speeds of around 200,000 miles per hour. This expulsion of material formed a dust cloud that obscured part of the star's surface, contributing to its dimming. The mass loss observed during this event was particularly striking, as it occurred at a much faster rate than the Sun's typical mass loss. This rapid ejection of material led to speculation about whether it could be a precursor to a more dramatic cosmic event, such as a supernova. Is Betelgeuse on the verge of a supernova? The big question on everyone's mind is whether this unusual dimming event is a precursor to a supernova explosion. A supernova is the explosive death of a star, and if Betelgeuse were to explode, it would create an incredible display of light visible from Earth. If Betelgeuse were to go supernova, the event would be one of the most spectacular celestial phenomena ever observed in human history. The explosion would emit a brilliant burst of light that could outshine the full moon for weeks, possibly even months. Its brightness would make it visible even during the daytime, transforming the night sky and leaving an indelible impression on humanity. However, despite the star's immense size and advanced evolutionary stage, predicting when it might explode is incredibly challenging. Astronomers estimate that Betelgeuse could go supernova any time within the next 100,000 years, a relatively short period on cosmic timescales but still vastly uncertain on human timescales. What would a Betelgeuse supernova mean for Earth? Although the prospect of Betelgeuse exploding is exciting, there's little reason to worry about the event having any adverse effects on Earth. Betelgeuse is located approximately 650 light-years away, far enough that its radiation wouldn't pose a threat to life on our planet. Instead, the supernova would offer a rare and valuable scientific opportunity. Astronomers could study the event in unprecedented detail, gaining new insights into the life cycles of massive stars, the mechanisms of supernova explosions, and the creation of heavy elements that are crucial to the formation of planets and life. Lessons from Betelgeuse. Betelgeuse serves as a fascinating reminder of the dynamic and ever-changing nature of the universe. Its fluctuations in brightness, the mystery of its dimming events, and the possibility of its eventual explosion highlight the importance of continued astronomical observations. With advancements in technology, such as powerful telescopes and space-based observatories, scientists are better equipped than ever to monitor stars like Betelgeuse. These tools enable us to not only observe celestial phenomena in real time but also to uncover the intricate processes that shape the cosmos. For now, Betelgeuse remains an enigmatic beacon in the night sky, captivating stargazers and scientists alike. Whether it explodes tomorrow, in a century, or 1,000 years from now, its story will continue to inspire awe and curiosity for generations to come. Earth. In any event during the day, this blast would be more brilliant than the full moon and would provide a remarkable chance to concentrate on the last snapshots of a massive star's life. Despite the dramatic nature of a supernova, Betelgeuse's distance from Earth, around 725 light-years, ensures that any such event wouldn't pose a direct threat to us. Several speculations have been proposed to explain the rapid dimming of Betelgeuse. One popular theory suggests that it is an indication that Betelgeuse is nearing the end of its life, and is in the early stages of the supernova process. Another hypothesis suggests that the dimming is the result of a dust storm blocking our view of the star. Red supergiants like Betelgeuse shed material throughout their lives, and this material could form a dust cloud thick enough to obscure the star's light. A third hypothesis posits that changes in the star's outer layer, or photosphere, could be responsible for the dimming. Spectroscopic data indicated that Betelgeuse's surface temperature had decreased by at least 170 Kelvin during the dimming event, which could suggest the presence of a large dark spot on the star's surface. The role of red supergiants in stellar evolution. Regardless of the cause of Betelgeuse's current dimming, its future is a critical topic of study for astronomers. Red supergiants like Betelgeuse are vital to our understanding of stellar evolution. These stars represent the final stage of a massive star's life before it explodes in a supernova. Their enormous size and relatively short lifespan make them ideal candidates for studying the processes that lead to a star's death. Additionally, the energy released by these stars in their final stages contributes to the formation of heavy elements, which are essential for the creation of planets and life as we know it. Betelgeuse's potential impact on stellar research. If Betelgeuse were to explode in a supernova, it would provide a rare opportunity to observe the processes involved in such an event up close. Supernovae are responsible for dispersing heavy elements into space, enriching the interstellar medium, and contributing to the formation of new stars, planets, and possibly life. Betelgeuse's inevitable supernova could have broad implications for our understanding of these cosmic processes and could also provide a spectacular sight for skywatchers. Despite the potential for a supernova, the distance between Betelgeuse and Earth ensures that we are safe from any harmful effects. Mass loss and eventual collapse. Betelgeuse's mass loss rate offers a glimpse into the extreme conditions these stars experience. Red supergiants like Betelgeuse shed material at much higher rates than stars like our Sun. As Betelgeuse approaches the end of its life, its outer layers will become increasingly unstable, and the star will likely lose even more material. Understanding this mass loss could lead to better predictions of how red supergiants evolve and what we can expect from other stars nearing their end. Supernovae and the formation of elements. Supernovae are not just dramatic cosmic events. They are also essential for the formation of heavy elements in the universe. When a massive star like Betelgeuse explodes, it scatters the elements forged within its core throughout space. These elements, including iron, carbon, and oxygen, are fundamental building blocks for the formation of planets, stars, and even life. The explosion of Betelgeuse, should it happen in the future, would contribute to this cosmic cycle, enriching the interstellar medium with elements that could eventually become part of new star systems. The impact of a supernova on the overall environment is significant. The shock waves from a supernova can trigger the formation of new stars by compressing nearby gas clouds, while the radiation released in the explosion can influence the chemical composition of these new stars and planets. The importance of continued observation. As Betelgeuse continues to evolve and exhibit unusual behavior, astronomers will likely intensify their efforts to observe and study it. The Hubble Space Telescope and other advanced observatories will be instrumental in providing real-time data about the star's activities. These observations will help astronomers refine their models of stellar evolution, including how mass loss, variable brightness, and other phenomena contribute to the life cycle of massive stars. Understanding red supergiants like Betelgeuse will assist us in making predictions about the fate of other massive stars in the universe. Furthermore, studying these stars can inform our understanding of the broader forces at play in the universe, including the formation of galaxies, star clusters, and planetary systems. What Betelgeuse teaches us about the universe. Beyond the immediate excitement surrounding its potential explosion, Betelgeuse offers a unique opportunity to explore some of the deepest mysteries of the universe. Its massive size, unusual behavior, and impending death provide a window into the final stages of stellar evolution. Studying Betelgeuse not only helps us understand this particular star but also offers valuable lessons about the life cycles of other massive stars and their impact on the larger cosmos. The broader implications of Betelgeuse's evolution. Betelgeuse's impending supernova represents more than just the death of a single star. It offers astronomers a chance to study the interconnectedness of cosmic processes. The life cycle of massive stars is a cornerstone of understanding how galaxies evolve over billions of years. Supernovae not only shape the chemical makeup of galaxies but also influence the conditions necessary for new stars and planetary systems to form. By observing Betelgeuse's changes in real time, astronomers can refine their models of stellar behavior and predict the life cycles of other red supergiants. This knowledge helps build a comprehensive picture of how stars contribute to the evolution of the universe as a whole. Cosmic explosions as catalysts for life. One of the most fascinating aspects of supernovae is their role in the creation of life. The heavy elements produced during a star's life and scattered during its death are the building blocks for planets and biological systems. Without these explosive events, elements like iron, essential for blood, carbon, the backbone of organic molecules, and oxygen, vital for respiration, would not exist in abundance. Betelgeuse's eventual explosion will further enrich the interstellar medium, providing the raw materials for future generations of stars and planets. This continuous cycle, star birth, death, and rebirth, is what drives the dynamic evolution of the universe. Anticipating Betelgeuse's future. While no one can predict exactly when Betelgeuse will explode, ongoing observations are crucial. Astronomers are monitoring the star's brightness, temperature, and mass loss, as these factors can provide early signs of a supernova. If Betelgeuse does explode, it will be one of the brightest objects in the sky, visible even during the day for weeks or months. The explosion would also produce a burst of neutrinos, subatomic particles that are emitted during the core collapse of a massive star. Observing these neutrinos would provide valuable insights into the physics of supernovae, helping scientists better understand the forces at work during such cataclysmic events. A legacy for future research. Even after Betelgeuse's explosion, its remnants will continue to be a source of study for generations of astronomers. The resulting neutron star or black hole will offer a chance to explore the extreme conditions present in these exotic objects. Additionally, the supernova remnant, a cloud of gas and dust enriched with heavy elements, will serve as a laboratory for studying the formation of new stars and planets. Betelgeuse is a reminder of the dynamic and ever-changing nature of the cosmos. By studying this iconic star, we gain not only a deeper understanding of its life and death but also a broader perspective on our place in the universe. Its story is a testament to the interconnectedness of all things in the cosmos, from the smallest particles to the largest galaxies.